One of the major things in circuit science are electromagnets, and they make a lot of things work that wouldn't work if they didn't exist. Okay, so what I'm going to talk to you now is about electromagnetism. So, last lesson we looked about magnetic fields and we looked at where that comes from. Okay, this you do not need to know for GCSE, but I'll give you a bit of a background. Electrons are very, very small particles, okay? They weigh 9.11 times 10 to the minus 31 kilograms in terms of mass. In terms of their charge, they are 1.6 times 10 to the minus 19 kilowatts. And it is these tiny particles that are responsible for generating magnetic fields. So, again, you don't need to know about electron spin, but it gives us a greater understanding of what is going on. So, in terms of a bar magnet, we talked about how we could have iron, nickel, cobalt, steel, and all of these, we can get the electron spinning in the same direction, and we can generate a magnetic field. We talked about how if we've got a north, and if we've got a south, then the magnetic field moves from north to south. So we now know that if we can get electrons to move in a certain way, then a magnetic field is induced. Right, so here's a fact for you. It doesn't matter what the material is made out of. It could be copper, it could be gold. When you have a current flowing through a conducting wire, a small magnetic field is produced around the core. Okay, I say small, it's dependent on the size of current. So that's right, when you've got a current flowing through a wire in your home, then what's going on is you've got a magnetic field that develops in a circular shape around the outside. So, this is down to the electron movement. If we've got a wire and the electrons are moving upwards, so the current is moving in that direction, then what happens is we get a circle generate a magnetic field around the outside. Now, this is 3D, it should be a circle coming out at you at the page, okay? It's really difficult to draw that on the board. So, if we put it moving upwards, then we get an anti-clockwise magnetic field going around the outside. If we were to have a look at that as a bird's eye view, and that was coming out of us at the board, then just imagine it as a circle that's perpendicular to the wire. If you're not sure, have a look at the right hand grip rule on Google for some clearer images. Okay, so in terms of the right hand grip rule, okay, like a hitchhiker, like this, okay, these represent the direction of the magnetic field, okay, so the magnetic field is going anti-clockwise if the current is going upwards. So right hand grip rule, current upwards, the magnetic field is anti-clockwise. Conversely, if I put it downwards, like this, okay, the current is flowing downwards, and therefore the magnetic field is going in a clockwise direction, following my fingers. If you increase the current, you increase the field strength, and if you get further away from the wire, then the field strength is weaker. So now that we know that ordinary current-carrying wires can produce a magnetic field, we can use these to make electromagnets. So instead of a straight wire, let's shape the wire into a solenoid shape. A solenoid is that repetitive coil pattern. Okay? And if you do that, you increase the strength. Why? Because your electrons are now moving around like this instead of a straight line. So you end up generating a magnetic field that's similar to the shape of a bar magnet. So, to make sure the physics is accurate, here I have got an anti-clockwise current going this way, and because I've got an anti-clockwise current, this is going to be a north pole here. Going the other way, that is clockwise, so this is the south pole that way. Okay, and that is A-level content in terms of knowing which one is north and south. You don't need to know about that. If we then stack a bit of iron, an iron core, a soft iron core in the gap, then that becomes magnetised as well in the same fashion, and you increase the strength. An electromagnet is when you take a solenoid shape of wire and you put an iron core in the middle. If you are doing triple, i.e. if you are doing the physics GCSE, you may be asked to explain a circuit where an electromagnet is being used. Now your doorbell is a standard piece of kit that uses an electromagnet. So here we've got the bell, also known as the gong, and we've got the armature or the hammer that swings backwards and forwards to hit the gong. Here we've got a contact. We've got a circuit that is incomplete because of the switch, and we've got a power supply. So, if we press the switch down, we complete that circuit. Because there is a power supply and the battery has voltage, okay, then what happens is the current flows in this direction, and the current flows around the circuit. That makes the electromagnet become magnetised, and because that becomes magnetised, then the armature is attracted towards the gong and it hits the gong. Because the armature has swung and hit the gong, swung isn't the word, swinged. Because the armature has moved and hit the gong, then it's moved away from the contact and the circuit is then incomplete. Because the circuit is incomplete, the armature returns back to the contact and the process goes on over and over again. Okay? And that's how electromagnets work.